Hello everybody, this is Mr. Kinney. I'm going to go over the even questions on the thermochemistry review paper. So question number 2, it asks you if heat is released by a chemical system, an equal amount of heat will be absorbed. So this is the idea that when the system loses heat, the surroundings are going to absorb the same amount. And I'm coming over here to I'm going to do number 3 here too. Endothermic is when the system gains heat. So you got to be careful, because when the system gains heat, for example, if in a chemical reaction you feel coldness after the reaction occurs, the system would be the chemicals, they will be gaining heat, it'll feel cold to us. If we're doing something like ice is melting, we've got heat going into the system, that'll be endothermic as well. Specific heat is the energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. I've been telling you it's how easy materials can transfer energy. I put my hand here, the paper feels nice and cool. Put my hand here, the tabletop feels cold. These two surfaces are the same temperature, but because they have a different specific heat, in this case the tabletop feeling really cold has a really low specific heat, it transfers energy quicker. Number 6, when you set up this problem, we're just doing a conversion. It's going to be 1.27 times 4.18 joules over 1 calorie. We get the answer there. For number 8, what is the specific heat of a substance? So specific heat, we start by using our base equation, Q equals mc delta T. We need to rearrange that so we get C all by itself. So we divide by m and T, and specific heat will be Q, 1,560 calories, divided by the mass, 312, also divided by 15 degrees temperature change. And then I think the answer is 0.3. For number 10, what are the units for specific heat? In chemistry, they tend to be calories over grams times degrees Celsius, or joules over grams times degrees Celsius. Number 12, the specific heat of silver is this value given in the problem. And the question says, how many joules of heat are needed to warm? That's going to be Q equals mc delta T. So we put in, we want to figure that out, so we know that we have 5.37 grams, that's the M. The specific heat, they tell us right here. That's how much energy it takes for 1 gram of this material to go up 1 degree. And the delta T is going to be 28.5 minus 24, so we get 4.5. The answer comes out to 5.8. Number 14, how many calories are in a kilocalorie? There are 1,000 little calories, little c calories, in a kilocalorie, also known as a capital C calorie. Okay, 1 capital C or food calorie. Oh, I went off the page there. Sorry about that. Going to the next page. Let me get this readjusted for everybody. What is an exothermic process? This is when the system gains heat and the surroundings are losing heat. So the system gains heat. It'll feel cool if it's a reaction. The products of the reaction, if it's a chemical reaction, are at a higher energy level than the reactants. That means energy had to go into it. It'll mean the Q is positive. 18, heat of vaporization is the energy used when boiling a liquid to a gas. We cannot use delta T at that point, because when you're in the process of either vaporizing or even melting, there's no change in temperature. So we need to use the value of heat of vaporization, which we take the mass of the stuff that melted and multiply it by the heat of vaporization. This kind of takes the place of specific heat when we're using Q equals mc delta T. So again, it's the energy used when boiling a liquid to a gas, and also the converse. When you have a gas condensing into a liquid, you can use that same value. Number 20, when calculating heat, if Q is negative, it means if Q is negative, heat is lost from the system. It'll feel hot if it's a chemical reaction, and that's an exothermic reaction. Number 22, when using our Q equals mc delta T equation, C represents the specific heat. And again, that's how much energy it takes. Usually that's going to be in like how much energy it takes to increase 1 gram, so that's gram times degree Celsius. So how much it takes to increase the temperature of 1 gram by 1 degree Celsius, that's the specific heat. Working out this problem, it turns out, number 24, that 150 milliliters would be 150 grams if it was pure water. So that was working with that. Number 26, it's asking you to calculate Q, which is MC delta T. So you get 150 grams of water. There's the specific heat for water. Here was the change in temperature from the problem, 28 minus 45. So we get a negative number, and that's okay. And then we got to convert that, because we have joules here. The question wants it in kilojoules, so make sure we got to convert that 1,000 joules or 1 kilojoule. So you do all this math, get it all set up in there, and you end up with negative 10.6. And that just means that heat was absorbed by the ice, it was lost by the water. And let's see, question number 28 was simulating the Doritos lab, and in this particular one, the question says, what's the mass of the water? Well, we put 50 milliliters in, it should be 50 grams. Coming over here to number 30. How many food calories were released by your food? Okay, so to do 30, we had to go calculate over here. So for number 29, we figured that the change in temperature, the amount of joules absorbed by the water, turned out to be 2,750 calories. That was 50 grams of material. There's the specific heat of the water, and the temperature in the problem said it changed by 55. So now this time, how many food calories were released? So we just need to convert 2,750 into calories by taking our 2,750, dividing it by 1,000, because there's 1,000 little calories in a food calorie, and it turns out to be 2.75. Number 32, if you ate, and it worked out, we have to do number 31 to do 32. If you take the number of big food calories released, divide it by how many grams that was burned when the chip burned, and it turned out to be 1 gram, we get our heat of combustion was 2.75 calories per gram. So now, taking that, if you had 50 grams of Doritos that you ate, and our conversion factor is 1 gram of Doritos was 2.75 calories, you should get about 137.5 calories, food calories out of there. This chart, I just went in, as we're going this way, this is melting as we're adding energy and boiling. As we're cooling down, losing kinetic energy, we get condensing here and freezing. Number 34, what state of matter is represented by number 2? Well, this would represent the solid, right over here. Let's see, number 36. What is the melting freezing point temperature of the substance? Well, the freezing point, when you have a chart like this, will be the lower one. So the freezing point looks like it'll be 0 degrees Celsius. Boiling point would have been 100. 38. What are the following are the following processes endothermic? Endothermic means the system gains heat. Exothermic means the system loses heat. So melting, that's going to be endothermic because heat is coming in, like you're melting ice. Boiling, that's going to be endothermic because you've got heat going in, making it boil away. Freezing is going to be exothermic because heat is going out of the system. If you're freezing, you're losing heat. Condensing, you're going from a steam to a liquid, you're losing heat. That's also exothermic. They seem kind of backwards when we talk about phase change. Temperature is a measurement of kinetic energy. Kinetic energy is the motion of matter. And we measure that with degrees Celsius. Explain how a calorimeter relies on the law of conservation of energy. You cannot create or destroy energy. There's potential energy stored in the chip. This is supposed to be a chip. We light it on fire. That potential energy gets converted into potential energy in this heat, and that heat is transferred to the water in here, and we heat up this water, which means we're increasing its kinetic energy. So the calorimeter is letting us measure how much potential energy was stored in the food. You cannot create or destroy energy. You can convert it from one form to another, and here it went from potential energy into kinetic energy. Okay. So there are the even questions. Goodbye, and I want you to ace this test.